Alright, another conversion that we have to do in class is one where you have to take the moles given and find the molecules. So we say how many molecules of SO2 are in 5 moles of SO2. Now I don't see the word mass or grams, so I know that I'm not going to need the molar mass here. That would be pointless to calculate the molar mass of SO2. You could do it, but it wouldn't get you anywhere. So we don't need the periodic table here. I do see the word molecules, and molecules is a type of particle. And we know that particles can be things like molecules or atoms or formula units or ions even can be a particle. And there's more than that, but those are the main ones that we'll deal with in class. So anytime I'm dealing with any of these words, I know that Avogadro's number is going to come into play. And I do know from class that 1 mole of SO2 has in it 6.02 times 10 to the 23rd molecules. That is a known fact, and we call it Avogadro's number. 1 mole of anything has 6.02 times 10 to the 23rd. So we can take this known conversion, this known factor, and plug it into our problem. Pretty straightforward here. So how many molecules of SO2 are in 5 moles of SO2? Set up our little bracket conversion. Moles of SO2. And what am I trying to find? Well, I'm trying to find molecules. Do not get the two terms mixed up. A mole and a molecule are not the same thing. In 1 mole, I have, there it is, 6.02 times 10 to the 23rd molecules. What happens to my mole values? They go away. And what does this end up being? This ends up being a multiplication problem. 5 times Avogadro's number. And the 5.00 has 3 sig figs. The Avogadro number value has 3 sig figs. The 1 down here doesn't count, so it's just a multiplication problem, and I'm going to round to 3 sig figs. And we end up with 3.01 times 10 to the 24th molecules of SO2. And there's my answer. Let me circle it here. Just stand down a little bit. 3.01 times 10 to the 24th molecules of SO2. And again, as always, we want to go back and make sure that the answer makes sense. Well, 1 mole of SO2 has Avogadro's number, 6.02 times 10 to the 23rd molecules in it. But I have more than 1 mole. And if I have more than 1 mole, that of course means that I'm going to have more than Avogadro's number. So if you compare this number here, 10 to the 23rd, with our answer, 10 to the 24th, we see that 10 to the 24th is a bigger value than 10 to the 23rd. So that should tell us that we've probably done the question right, and we can move on to the next one. So that's your standard mole to molecule or mole to particle conversion.